This week we had Bill from Unruggable on the schedule, but unfortunately he's flying right now, so he couldn't make it. So I asked my dear friend Rafael from Triton One to come on. So please give a big round of applause for Rafael! Yay! Hello, hello, good
Hello,
sir.
guys.
How are you?
How you doing?
I'm good.
I'm
How
I'm
are
doing
you?
good.
Yeah. So tell me,
Nice.
what do you do at Triton One?
Well, a little bit of this, a little bit of that. A lot of things. Mostly the strings, so Geyser optimizations, trying to make everything faster, and I have fun.
All right, cool. So, how long have you been working at Triton One?
Um, I think we'll complete 1 year and a half. Yeah, about 1 year and a half.
Nice. And so fast already. Because I feel like you just don't join the team, but yeah, everything moves so fast.
Yeah.
It's crazy. So how did you became a Solana developer basically?
Well, a lot of things. So I started on Solana on 2021, and I didn't knew much about blockchain and stuff. And I had a lot of friends that were coming and doing trading in NFTs in Solana. So a Discord group and people start trying to buy NFTs. And since I was a developer, I try to make some tools to make those things easier and to get some advantage. And then I just become admired by how cool the tech it is, the concepts of blockchain, decentralization, and all of those things. I felt like every time, every day, I learned something new. There's a lot of new tech on Solana, and they are used on all other technologies. So it's very amazing to have this experience to learn something new every day, and I just continue doing that. Then moving to understanding more the code of Agave, contributing to either Agave or Fire Dancer, and here I am.
So how do you go from creating tools to maybe snipe or get an advantage for purchasing NFTs to actually contributing to the core protocol basically?
So I had a software and I had to run my RPCs. I had to run stuff. At the time, running ARPC was very expensive. Not that today is not expensive, but it was a little bit more. So the the worst box I could get was, I think, 1,200 a month, and it was very bad. It was a Ryzen, not a Ryzen, but a Epic 74 something. It was very bad, and I was thinking, why do we have this software that is doing three things? So it's doing the block creation, validating the blocks, and also the RPC. It's why, it's redundant. It's we could do something differently. So I started creating a light client that at the time and today is called Velus. And the idea was just getting the data out of the blockchain and basically a small RPC or a small geyser. That was the idea. So I started this project and start working on this, and then eventually I tweeted, I commented on a post from Wilfred, and the turns out the Triton or Linus was already thinking on something like this, and then I started talking with Linus and Wilfred, and then I got to Triton, and then building amazing stuff, open source stuff in Triton become my new passion.
Nice. It's crazy. So did you work on other blockchains before, or was Solana your starting point?
Solana was my starting point, but at the time I got in Solana, I also tried another chains. I tried Ethereum, I tried Avalanche. What else? I think I tried Sui, Aptos. Yeah, I was trying to do aggregation of analytics from all different chains, and I created some apps about this to get some data and did some stuff on the other chains to understand better. EVM to me is I don't like.
No.
That's it.
What
I don't
about it?
like. No, no. I don't know. It's because I started learning things on Solana. My the concepts of Solana felt more. It felt better. The meaning and how things work. It felt like that was a better idea than EVM. And then yeah, I think I got used to it.
All right. Awesome. So high performance blockchains only.
Yeah, exactly.
All right. So you mentioned that you work on streaming. I do think I know a thing or two about streaming, but whenever I'm talking to you, I realize I don't know anything at all. So why don't you walk us through the process of what streaming is, and what the difference is between there's levels to it, right? So
Mhm.
maybe yeah, let's start at the beginning. What is streaming? Solana. What does that even mean?
Okay. So Solana produces a lot of data, and the block creator will send out shreds, which is tiny particles of the transactions and tiny particles of micro blocks, because Solana will not send a full block but micro blocks. And the RPC will get those micro blocks, these shards of these micro blocks, aggregate in and create the micro blocks and start replaying those transactions, because inside of those micro blocks you have transactions.
So
Some
you're already going really fast. So what you're saying is
Sorry.
then there when, for that Solana produces a block every 400 milliseconds, but
Mhm.
the validator that is producing the block already starts out sending smaller blocks, that make up the full block to other validators so they can replay what's in those tiny um, tiny blocks. And
Yes,
the
yes.
tiny blocks are called shreds.
No, the tiny blocks are called entries, but the what forms entries are shreds.
All right. So if you would break it down, there's a full block, then there's entries, and
Mhm.
those entries are made up of shreds.
Exactly.
All right.
Yeah.
Already learning something.
Uh, Nice. And something that is very expensive, if we will send this, is the accounts. So the block producer will not send you the account changes. It's the responsibility of who is replaying this to have the account state. Because if we were to send this, I think some month ago I was testing, and 2 days of only account updates on Solana is equivalent of around 10 petabytes of data. So it's absurd amount of data. We will not be able to send this over the internet.
so it's
That's why
more
we only send shreds.
so it's more efficient to run shreds versus account state updates.
Yeah,
All
yeah,
right.
and also because you need someone to validate what you're doing, right? You need to someone needs to get the transactions that you include in this block and see if the changes will make sense. That's the part of the validators who are going to vote if that block is fine.
All right. So
Yeah,
let's say I send $100 to you instead of the validator saying, "All right, Steve now has $0 and Rafael now has $100." The validator will say $100 moved from here to there, and that's cheaper.
exactly.
Why is that cheaper?
I think, what do you mean by cheaper? Because we cannot send you the account state, or
Well, you said in terms of data transmission, it's a lot
Mhm.
lighter to just send the transaction instead of the account state change.
Yeah, and also because of, well, there's two things there: the throughput and the latency. You need to have a very big throughput in order to send all this data. I think it's around 2 to 3 gigabits. Um, yeah, and that's not something that will everyone will have, and you also have the latency to send all this data. It's way cheaper to send threads, because threads are the minimum MTU size. It's 1232 bytes, and it's very cheap to send this over the internet right now, because it's currently designed to be able to receive these packets. It's plain UDP packets. It's faster, and it makes sense to send this. If we want performance and low latency, that's the thing.
All right. So yeah, I interrupted you before because I wanted to learn more about about what these
Of
shreds are.
course.
So these shreds they get sent out to other validators. Then what happens?
Then the validator will validate this. If this information makes sense, like you said, you're sending me $100, and I need to verify if the Steve account actually has $100 to send to mine, right? And that's the validation. They will they do this in micro blocks, also because uh, it is faster. If you will wait for the 400 milliseconds and then the other guy will replay this, it will add more latency. If you can do this continuously, is of course better.
All right. So everyone receiving these shreds are replaying the transactions in order to keep track of what the account state changes are.
Exactly.
All
And
right.
two different clients, I mean, the same validator and the RPC will do the same thing. The difference is the validator will actually vote on the block. So the RPC needs to do the replay and needs to have the account state, but it will not vote. So there's code to verify a lot of things, like if you're sending duplicate threads, if you're a lot of verifications you have inside Agave that only the validator needs to do. The RPC doesn't need to do all those things. That's why Anza and I think everyone that likes performance wants to remove the RPC, and I would say the same for us, because I don't want to do the validation part. I just want to get the data as fast as possible and to get the data and use it.
All right. So the RPC replays it. Then what happens is let's talk about Geyser streaming.
Sure.
Where does the Geyser streaming part start?
Okay. So there's a lot of processes that happen when you're replaying something, and the geyser can give you information about almost all those steps. So it can tell you when you receive the first thread for a new block. This is useful, so you want to track the tip of a slot. You want to know the fastest way of getting knowing when a new slot is being produced, and this is a category of slot status. And there is other slot status that will tell you when the slot was replayed, when the slot, the bank of this slot was created. Bank is what helps the replay to have the account state and to manage those things, also manage forks, etc. So immediately when you receive a new thread, it will try to create a new bank only if you already replayed the previous bank, the parent bank. So it will tell you, okay, I am creating this new bank. It will tell you, okay, I received all the threads for this slot. Also, when the slot is processed, when you replay every transaction inside the slot. The same goes for confirmed. This is more to a consensus status, is when you when the majority of the validators voted on that block. So it's around two-thirds of the validators, and also finalize it, which is a block that was confirmed and has votes, and there's already 31 slots after this one.
So,
So
all right. I think I understand. So where does the so Geyser streaming happens between the RPC node and a client basically. So does that mean that the RPC node also has to emit a new stream of replayed information? Is that correct or
what do you mean by new string?
so the shreds are coming from the validator to the RPC node, if I'm not mistaken. So where does the Geyser stream come from? It doesn't come from the validator, right?
Well, either in the RPC or the validator, they will is just callbacks in the code that when the data is processed or something happened, these callbacks will go to the Geyser manager, which will iterate all the Geyser plugins. So the Geyser plugins will have access to those callbacks. Those callbacks are, okay, I just processed this slot. I just received the first thread. I just received a new transaction. I just received a new account update. And then it's how the plugin will use this that matter. Not exactly matter, but how we will use that will differ from one plugin to another. So, for instance, the Yellowstone Dragon's Mouth, we use this and we created a gRPC server that we can provide this information via gRPC to people, to clients.
All right. So what is shred streaming? Because we recently put a new product out of beta. It's called Deshred. So
Okay.
it's supposed to be lower latency. So what is it and how does it work?
Let me explain that. Before explaining that, let me just go back a little bit on how the transaction get replayed, so we can explain why it's faster the shred.
All right, let's hear it.
So you will receive the shreds, create entries. Inside entries, you will have transactions. Immediately, these transactions will go to the scheduler, or the replay will try to replay those transactions. The replay can take a little bit of time because depending of the transaction, it will need to wait for another transaction to be executed. So it's like a queue. You have one transaction that needs to wait for another transaction and another, and this depends of what are the accounts of the the inside of the transaction that needs to be written or that the validator needs to read or write on them. So you cannot do all the transactions at the same time because you can get conflicts. And because of this, the majority of the transactions have account conflicts because people are buying pump fund tokens or in AMMs or something like this. Majority will have conflicts. So a majority of transactions will take more time because it needs to wait for another transaction. So okay, the replay will add a little bit of latency because it needs the transactions to be waiting and then read the accounts DB. That is also can also takes a little bit of time. After replay, this go to the Geyser and goes to the plugin that goes to the gRPC. The Deshred is before replaying. So since we have all the transactions, we can just send these transactions to you. I just added a callback. Okay, these are the transactions before this replay. This is why the shred transactions are faster, though there are some caveats. They don't have all the state because since they are not executed yet, you will not have information about the account balances of this transaction. You will also not get the inner instructions of the transaction, because in order to have this, you need to have the SVM to execute the program, that inside the program it can do CPIs for another programs. So for instance, you have a transaction that interacts with Jupyter, and Jupyter will do the routing. Routing includes doing a swap using rating or pump fund or whatever. Those are inner instructions of the instruction of the Jupyter. Those you will not know. So for instance, for a trader that wants to do copy trading, it needs to know, okay, what are the dexes that this guy bought, so I can copy the trade. It will not know exactly, but you can know, for instance, in the Jupyter, you can parse the account data to get those informations. But I think we are moving to another subject, so before going to that,
No,
finish
just
on the Deshred.
yeah. All right.
Does it
So
make sense?
it does make sense. So how do you use Deshreds if you don't know the inner instruction, if you don't know the what the account state changes are gonna be?
Well, it's not something trivial. We have a customer that was asking this. It's not something trivial, but it can be done, right? You will need to in the instruction of Jupyter, it will have the instruction data. Usually in the instruction data, it will have the information of the routing plan. With the routing plan, you can know which dexes it will use, and I think also which AMMs it will use exactly, because in Solana you need to specify all the accounts that you're going to use. So basically you have all the information in the account data and in the accounts that Jupyter is using. In the account plan of Jupyter, in the routing plan inside of the account data, you will have information about which AMM it's buying first and how much percentage is buying. Because since Jupyter will try to get you the best price, sometimes it's better buy 50% on DEX A and 50% on DEX B. So you can know those information. You don't necessarily need to execute, because it's there. It's what Jupyter is going to do, and you can know those stuffs. You just need to look through to the account data, and you will have this information.
All right. So what is the latency increase for this? How much faster can you determine what you're copy trading versus streaming with Geyser?
Mhm. Well, it can depends a lot. Like I said, you can have 200 transactions waiting to be executed, and the last one will, of course, be way later than the first one. So it really depends. From our my benchmarks, the P50 is, I think, 6 milliseconds or something, like 6 point something. I don't remember exactly, but it was 6 milliseconds, the P50. It means that 50% of all the transactions will take about 66 milliseconds to be executed. And the P90, which is also like very good information, is not it is the not the worst case, but it will tell you less, around 10% of the transaction will take 20 milliseconds to be executed, which is a lot of time. So 6 and 20 milliseconds is a lot of time. In If you use the shred, it will be much faster.
So who is this for? Because I imagine that I'm when a friend tells me, "Oh, you should buy this coin," I'm basically copy trading. But yeah, it doesn't come down to 6 milliseconds. So who uses
Mm.
this and why is it important?
Well, basically, more sophisticated traders, I would say, because you need to do some extra work to actually get the information that you need from this, saving those milliseconds. So everyone that do copy trading to arbitrage to market making specifically will be very good to have this information. So I think those three and all people that do some sort of trading or some strategy with MEV are going to be benefit from this.
Nice. So the Deshred information, does it come directly from the validator, or are you still connected to the RPC node?
So it will come from the RPC because we need to form the shreds into entries and deserialize the entries to get the transactions. So it will come from the RPC and it will be streamed over gRPC to the client.
Nice. So you don't need code changes. You can still use, your same provider or whatever, or
Yeah,
stay
you
connected to the
can,
same box.
yeah, you can use Triton. You can use the gRPC. It will be ready for you.
All right. Cool. So how did you come to get so interested in this? Because it's so super niche, and I
Yeah.
doubt there will be many people that know what you know about this topic. Like, did you decide one day, all right, let's improve latency, or did that happen throughout, where you started getting interested in Solana?
Mostly all the events that I go, I met people that are interested on those things. In the breakpoint, I was talking with the fire dancer team, also the Anza team. Both teams are amazing, and we see a lot of different stuff. There's people that also do trading, but mostly what is the thing for me is the performance. I want to get the best and the fastest way possible to get the data. I mean, using all that we have possible to make those things happen. So uh, this is very simple actually. The shred is something very simple. The other stuff that I working is like how to make the receiving the shreds faster using either XTP or things like this, improving, doing performance improvements, or trying to optimize the nick, all those sort of things to so we can have the best latency, the low latency as possible.
That's crazy. You also, I remember at one point, were doing a lot of writing instead of reading. Maybe you could share a little bit about that.
Sorry, what do you mean writing?
Sending transactions.
Ah, okay. Yeah, yeah. This is also very cool. This is also very cool. We have Jet is very stable now, and it's very good piece of software right now because of how things are going to the SWQS. Things are getting a little bit differently. But yeah, right now we're doing some changes in our infrastructure, removing some hops. So in theory, we will have a better latency. I think these changes are already applied. We should have a better latency already.
Well, if I remember correctly, you're at one point we're also sending a lot of transactions into a single block.
Oh yeah.
Tell us a
So
little bit about
this
that.
is very cool. This is very cool. I was trying to understand how the unstaked works better and how can I maximize sending transactions. I was testing different clients as well, FireDancer and Agave. FireDancer, you don't have the limit to how many transactions you can send besides the scheduler. But Agave, you have some limits. In Agave, I could only send I think 80 transactions per slot with the unstake connection, which is already very good. And at the time, I was trying to maximize and send as much as I could to FireDancer, and I didn't knew. I didn't knew, but eventually I think I hit 20 7K TPS on Solana, and I think was people posted in random and tagged me if it was me, and then I realized, okay, it was me, and
So
yeah, it was
27,000 transactions per second.
yeah, yeah, in mainnet.
So there's a limit to how much transactions can fit into a block. So how did you fit all that into how did you do that?
To be honestly, I wasn't trying to do as that much. I was just trying to test like my own code, because to produce this amount of transactions is also something that is, it takes a little bit of time, because you need to create the transaction and sign. The time to do that can take a little bit, especially if you're sending a lot of transactions. So I was just testing this. I was testing how many transactions I could create in a slot, um, using pull threads and a lot of things. And eventually I hit this. There is a limit, of course. I don't know what is the limit exactly. The limit is how much you can pay, but there is, of course, a limit. Um, I was sending some simple transactions like self transfer using only one wallet, I think. But you can do more, but you need to use a lot of different wallets, and you need to use not a self transfer but a no op program. And after this, uh, I think you know KV
Yeah.
from yeah,
He's on
he saw
the
that, and
he's on the what he's temporal, isn't he?
yeah,
Yeah.
temporal, harmonic, or the cool stuff. But yeah, he saw that, and he used his own validator. I think it was Fire Dancer or Franking Dancer at the time, and he said, "Okay, I will bid this DPS." And I think he did. I don't know if it was 100 or 200, something like this, 200K or 100K DPS. He beat me. He beat me, and but the thing is, let me do the calculation here, because if you're sending this, you need to pay the fee, and you need to pay the base fee, which is 5,000 lamperts. So let me do a quick math here. But it's a lot of money. It's one sol, I think. Yeah, it's one sol. You're basically going to spend one sol to do all these transactions,
Just for testing.
which is, yeah, just for testing. So at the time, I think it was testing Solana was, I don't know, but it was much more than this, closer to 200 than right now. So
All
it
the
was more expensive
all the
to do this
people
test.
that came in from Ethereum and are listening to this podcast right now, they're laughing like one soul for a transaction
Yeah,
fee. What expensive, blah blah.
not one transaction, but 200K
Yeah,
transactions.
that's true. You can't do that on Ethereum, I think.
Yeah,
Last time
you
I checked,
cannot.
at least. I didn't check that often.
And the thing is, I tried to beat his number, but it is harder, because I don't know how he was sending, but from what I tested, you need more than one machine or one box to send the transactions. I think even Firedancer has a limit of how many transactions it can receive per IP. So that's what I figured out. I was really thinking on hosting 10 VPS that I could pay for an hour, which will not be that expensive, and I could run my software to send that many transactions. But then, like, it was too much. It was too much.
Well, if you're looking for sponsors, if you're listening to this and you want Rafael to try this out with multiple boxes, reach out to us
Yeah.
and we'll get a donation donation
If
account
you
going. Public
we
key.
we can try to make 400k TPS, but I
For
just need some salt, you know.
all right, all right. Well, let's see. Let's see what we can muster up. So let's switch gears a bit.
Mhm.
We yesterday announced that we're gonna do Solana RPC 2.0.
Okay.
Can you please share some insight on what this means for building on Solana?
Sure. I think that's the dream because it will make things easier for everyone. Um, it's the idea when I started working on Velos is like removing some stuff from Agave and create having different clients or something cheaper to run those stuff. There's this case for WebSockets that I am working, which is called Whirligig. And ideally, you should be able to run WebSockets all the same specs parity as Agave, but not on Agave, just using the gRPC. And that is good because for scaling things, making it more cheaper, it's amazing. You can scale, have different clients running Whirligig, providing WebSockets to different people or needs, just using gRPC. And you can use the gRPC string for a lot of different stuff. So basically, it's removing the need to actually run a big box and run a GAF for the RPC stuff. It basically means to every developer that things will be cheaper and probably faster for them.
Nice.
It's a overall win for Solana.
Awesome. So yeah, I read the announcement and the blog post we put up. So if I understand it correctly, what the idea is that there's going to be no more RPC nodes or unstaked validators running along with the network. There's going to be a accounts database of all the account state on Solana, which you can query for, get multiple accounts, get program accounts, get account info, stuff like that. And then you can have a part of that account state stored locally, which you can keep fresh using streaming. So you have your own data set running in your backend. So any RPC call, instead of making it a remote procedure call, it's going to be a local procedure call of some sorts. So basically, any account that is relevant to your program or to your operation, it's going to not live inside an RPC node, it's going to live locally. And you're going to keep that account state fresh by streaming gRPC or streaming Whirligig or streaming Deshreds. And then that's going to be a lot cheaper than having a million of these really big servers, big expensive servers that have the
Yeah.
Agave client on them. Is that like, does that come near what we're about to expect, or did I completely miss the point of the blog post?
No, I think it makes sense. As you said, and as I said, it will be cheaper and faster and easier for everyone, every developer, everyone that wants to read the data from the chain will be able to do it much easier and it should be faster as well.
Nice. So it's going to be a huge improvement.
Yeah, yeah. I can think of a lot of things, a lot of different stuff you can do. I was thinking on simulating transactions. Simulating transactions is something that it's usually done in the agave or the RPC, but with the account state locally or just be getting the feed from the gRPC, you can do that, and it's very good because there's a lot of either people that traders or analytics that needs to have the data. It will be much easier to do that.
Awesome. So what part of this are you building, or are you building all of it, or what's your current focus?
No, 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 no. Well, I'm the accounts. I am not in the accounts, but I think accounts is one of the best for all of this, because the real problem for me is the accounts, because I can just do a simple program and get the shreds into transactions, but to get other informations from the transactions I really need the accounts. So I'm working on the things that are streamed. So basically the gRPC, all those strings like Whirligig, WebSockets, those things. But for me, the most amazing stuff is the accounts, and also there's the historical transactions that also are very very important as well, because if you need to replay old data you will need at least some old accounts or old transactions and old accounts.
Yeah, you can't have the current account state of Solana without having to replay all transactions
Yeah,
that ever happened on Solana, because we don't store the account state changes, we store the transactions that create those account states.
yeah, we have snapshots. I don't remember if we still are storing, but if we are, we were doing like a interval of 1 hour since Genesis. And I think that I don't remember the number, if it was 5 petabyte or, but it was a very big number.
Yeah, we have one of our
So
co-founders. He's called Linus. He is a hoarder. He has trouble with throwing old stuff out. We have 5 petabytes of snapshots.
yeah,
I hope we still have it.
but
There's a lot of people asking about historical state instead of historical
mhm.
transactions these days. So yeah, we'll see. So what do you think about Solana 4.0, or as some people call it, Alpenglow, the Alpenglow upgrade? Is that the same
Well,
thing?
the 4.0, I'm not sure if it's in on this new version already or when it's going to release, but you want to know what I think about Alpenglow.
Yeah,
I think it's very cool. It's amazing protocol. It will improve a lot Solana. Um, I am not so up to date of where it is, to be honest. I think I'm being too much into my niche nowadays. I need to update myself, but I think it's very cool. If we can get the finality to 150 milliseconds, it will be amazing, and all the improvements with the uh, voter that will change how it will change mostly for the validators and people that run validators is also very good, I think. And regarding the performance, it will improve a lot as well. So for me, if we can do it faster, it's already amazing.
nice. Yeah. So for those who don't know, Alpenglow is looking to remove the entire RPC stack from the Agave client. It's going to change the consensus mechanism. Instead of voting on full blocks, we're going to be voting on entries, which are made up out of shreds. So the mini blocks, we called them before in this podcast, are going to be what we're reaching consensus on before the entire block is finished. What do you think happens, by the way, now that we're discussing it? I'm thinking, what if some entries are valid and then some entries are not valid? Will the entire block be dropped, or will part of the block still be usable?
Usually, if you have something slightly different, the whole block gets skipped. So yes, I think the whole block will be skipped.
So how
And
would you be able
yeah,
to reach finality in 150 milliseconds then? Because if the first entry or the second entry gets doesn't pass the voting, then the first block, or let's say the last entry of a block, is not valid, but the first entry of the block is already past the voting, so it's valid and finalized. How would that work?
Well, this is fork resolution. It's usually very complicated, but what it will happen is that that block will be skipped, and the slot will continue because the slot is just the passage of time, and then it will go to the next leader, and the leader will say that his parent is the slot previously than the one that got skipped, because slot, I think, is just to say that time is passing. You have block height that will tell you how many blocks got produced. So
Yeah.
it will just be skipped, and the next leader will know this and will start his bank on the parent that is not the one that got skipped.
All right.
This is, I'm assuming, of course. I don't know too much how the fork resolution works on Alpenglow. I'm just assuming things, just to be clear.
I'm gonna try to research that before the next stream.
Me too.
So, what excites you most for the coming year for Solana?
Good question. It's too vague if I say everything, but I think MCP is something that I'm interested to see, but I'm not sure if next real year it will be there.
So, for
I
those who don't know what MCP means, what does it mean? What is MCP?
Multiple producers, multiple
Multiple
block
concurrent
producers.
producers. So, multiple
Yes,
validators
multiple leaders. Yes.
producing the same block or their own blocks?
Ideally, they will all sum to build one block, but you need people receiving transactions. You need, I think, read layers or something like this. I also didn't read too much about the paper, but essentially they will all convert to one block.
I need to research this as well. I there's so much stuff happening all the time on
Yeah.
Solana. It's crazy. All right. So multiple concurrent proposal. What about it does excite you?
I'm really interested to see how it will be managed to be done, because having asynchronous execution is complicated. So what I want to see is how that will be done, and mostly that. Then and how are the I think it's three leaders. How will be the difference for the validators regarding the rewards, because they will need to, I think, divide the rewards for the block. How much that will impact the currently validators number, because from the past year the number was just decreasing. I don't know what is the number exactly right now, but I remember it was 1,000. Then I think right now we are up to 700 or something. If it's less than that, it's already decreasing. But it can decrease more because of that. I also saw people talking about regions. This will incentivize the three leaders to be in the same region, not the opposite, because you need to build it faster, etc. So I don't know. I also saw people talk about how this will help or mitigate the bad MAV, and I don't know how it will do that, because there is private order flow right now, which not necessarily are bad MAV. It's just that someone has the transaction before the others and it's already doing something. If it's going to do something bad, it depends. It can just do arbitrage, and that's not necessarily bad. But having the transaction before the others, it's, I don't know if it's bad or good.
We'll see. There's a lot of discussion on the timeline. I just looked it up. We currently have 794 validators, and I see Figment
Nice.
took the number one spot, which is surprising because you can't see that here. Let me drag this a little here. They do have a commission of 7%, so being the top validator is pretty impressive, not gonna lie. For those who don't know Solana Beach, it is an amazing dashboard of basically the state of Solana, where the most stake lives, where most of the network lives. And you can check in real time what validator is producing the blocks. You can see 4 slots per leader, which is awesome. Shout out to Solana Beach for building this. And he's also a really nice guy.
Yeah, this website is very cool. I remember seeing this since I started almost in Solana, and seeing the leaders changing the location. I mean, not changing the location, but seeing the current leader changing its location. It's very cool to see how decentralized and how the data is flowing around the chain.
Yeah, I love it. I love staring at the map. It's and at my first breakpoint, I got one of the t-shirts as merchandise. I still wear it like every few days. It's really good.
Nice.
So I've been wearing the same shirt for 4 years, guys. Send me a new shirt. All right. I think we're gonna wrap this up. Where will we see you next? I had a little bird tell me that you will be in Miami.
Yeah, I'm going to Miami, going to accelerate. I'll be there. There's a lot of side events. I think I'm going to the ones that I saw, which is probably the ones people were seeing, the biggest ones. Those. Those
right.
events.
Cool. So if you see Rafael, come talk to him. Ask him anything about low latency, high frequency trading, Deshred, Solana 2.0, Whirligig, the works. Thanks so much for being on. And next week, I have a little peep. I have Realms, the DAO infrastructure company.
Nice.
What would you like me to ask them during the podcast? What do you think is a good question for them?
I don't know much about Realms. I just saw them, but I'm a guy that is very into its niche. Can you explain me a little bit what they do so I can make a good question?
Yeah, for sure. So they built a platform where online communities can vote on proposals.
Yeah.
It's basically a governance company.
Got it. It is what we use it in Island DAO, right?
Yes.
I think.
Exactly.
Got it.
It can be a spicy
I
question
need a
if you want.
spicy question.
Yes.
What they are wearing.
All right, I'll ask him just that. Thanks everyone for tuning in. This was Pirates Parley, episode 14, and I hope to see you guys next week at the same time. Bye-bye.